Earth orbits the Sun. The Sun orbits around the Milky Way, and the Milky Way itself is blazing through space at 600 kilometers every second in a particular direction. What's strange is that the Andromeda Galaxy and all of the 100 or so smaller galaxies that form our local group are also moving in the same direction at the same speed. That's pretty odd, but when we zoom out even further to try to sort things out, it gets even weirder. Our local group is just a small part of the Virgo Cluster containing over 1,300 galaxies, and they're also being pulled in the same direction. Even farther out, you again find that our cluster is just a tiny part of the Laniakea Supercluster, over 500 million light years long, containing over 100,000 galaxies, and all of them are also being drawn in by something. Something is out there, something unfathomably massive with enough gravity to pull entire clusters of galaxies towards it. We call that something the Great Attractor, and after decades of confusion, we're pretty sure we finally know what it is. We have incredible telescopes that can see all the way out to the edge of the observable universe, so why is this such a challenge? Let's just use a telescope to look at it and see what it is. Well, there's a problem. This is where we are in the Milky Way, and the Great Attractor is off in this direction, and right in our line of sight is light years of thick gas and dust in the center of the galaxy, so looking in that direction, this is what we see. It's not a bad sight, but it is quite the photobomb. This region is known as the zone of avoidance, and it's become an absolute headache for astronomers. It's a bit unnerving to realize we're being dragged along, like it or not, towards an unknown object by an unknown force. One potential candidate that we can see in that general direction is the Shapley Supercluster, the largest collection of galaxies in our area of the universe. But when scientists measured it, they found it's only about 1/10 the mass needed to be the Great Attractor, and it's not quite located in the right place to match the direction of our movement. So that wasn't it, and to figure it out, we would have to figure out how to peer beyond the zone of avoidance. If you're super patient, you can wait about 100 million years when we'll finally orbit to the other end of the galaxy and have a clear view. But thankfully, we have made progress over the years. As technology advanced, astronomers were able to use X-ray and radio telescopes to painstakingly squint through the murky haze of the Milky Way and slowly map data from the other side of the zone of avoidance. And in 1996, they finally discovered the Norma Cluster, an absolutely huge collection of galaxies about 220 million light years away, which was just the right distance to be the Great Attractor. With a mass of roughly 1 quadrillion suns, it turned out to be nowhere nearly massive enough to exert that much force on so many galaxies. Science isn't easy, but scientists also don't give up easily. They kept searching and eventually decided to take a closer look at the Shapley Supercluster that was ruled out before. In 2005, further analysis showed that while still not quite big enough to be the Great Attractor, it is much larger than we previously thought, containing over 8,000 galaxies that are on average more massive than the Milky Way. It's significant enough that the entire Norma Cluster is being pulled towards it. With this added clue, scientists now had enough information to start piecing together the puzzle. If we look at the whole picture, the Norma Cluster is big enough to be responsible for about 44% of the gravitational influence needed to pull everything in that direction. And the Shapley Supercluster has enough mass to provide the other 56% of the force needed. So the Great Attractor might not actually be a single thing, but the compounded result of several different things. This all raises a question. What does our future look like? We and the other galaxies are all currently moving towards one another despite dark energy working to expand the universe. Are we and all of the other galaxies in our region all going to violently collide in a multi-galactic mega explosion? Well, thankfully not. For some reason that nobody even slightly understands, the rate at which the universe is expanding is accelerating over time. Before before we have to worry about any of these galactic groups actually colliding, the expansion will become rapid enough to overcome the force of the Great Attractor, and instead, we'll all be moving away from one another like we thought we already were in the first place. If you are a bit sick of the universe moving you around as it pleases and would like to do something about it, then you do have some options. Watch this video next to learn how to travel faster than light the Einstein-approved way.